Good afternoon, everybody, and welcome to TGIK 104. Good to see everybody. Let's see who's with us already this morning. We got Rory, we got Suresh from Hamburg, we got Martin and Waleed and Lamadi. You know, the usual suspects. So it's always great to see you all. I'm super glad you're here. So today we're going to look into Kyverno, which I think is actually kind of an interesting segue away from the what do you call it, the grokking series. I'm taking a little break from the grokking series this week, but we are also going to probably be exploring, Kyverno is a dynamic admission controller, and so they implement things like the validating webhook, the mutating webhook. Those are the two dynamic admission controller interfaces that the Kube API server expresses. And so we're going to be looking into how they go about that. We're going to talk about some of the ways that those things are configured. We're going to explore those things. And we're also going to explore Kyverno, a new policy tool put out by Nirvana Cloud that looks to try and solve some of the same problems, or actually more of the problems than even the pod security policies apply. In this particular case, I think what they're trying to do, and we'll get into it when we start playing with it, is that they're trying to make it so it's a much lower learning curve to be able to implement reasonable validating and mutating policies within your Kubernetes cluster. So you can say things like, I want to generate a whitelist of repositories that are going to apply to pods so that those images can only come from these particular repositories. And today you can do that in a number of different ways, but you know, they each have the kind of their own learning curve. OPA is one of those ways. There's tons of ways to do that. And so this one looks really interesting because the API seems pretty concise. Anyway, good to see you all. Who else joined us here? We got Mike Morrell from New Jersey. Good to see you, Mike. Let's go ahead and get started. We got Jim from San Jose, and I believe, Jim is one of the people I spoke to on the project, and I suspect we might have a couple others joining us as well, but if we have questions, maybe Jim will help us out. That'll be pretty awesome. All right, so let me kick over to the screen here. Give me 1 second. And boop. All right, great. So as always, our notes are up this week at tgik.io/notes. And so if you would like to append a URL or add some notes or anything, feel free to do it there. That's where it's at. Looks like some stuff's been added. I saw that actually, the long-lived connection, so that does look pretty interesting. All right, so first off, looks like in core Kubernetes 118 Alpha 3 is out, and that's usually a pretty good sign that we're getting pretty close to getting it out there. So Kubernetes 118 Alpha 3 is out. I can't believe we're already at 118. It seems like it's one of those things that just continues to march forward. Kind of amazing, really. And now it looks like the release notes are now sorted by kind instead of SIG, hopefully making it easier to read. So let's take a look at what that looks like. Sort release notes by kind instead of SIG. So I guess it would be type up kind graduate. I wish there were a better example of what is happening here, but I like the readability better. Of what, though? Now it looks like this. Let's take a look. All right, so this is an example of what it looks like. So changes by kind. You have a list of API changes, and these are no longer broken up by SIG, right? So if there was an API change that was related to SIG networking, it would have been down underneath the SIG networking section, rather than having it be referenced in a list this way. The bugs that are addressed, the cleanup, documentation, failing test, and flake. I mean, I think I can get behind the idea that this is more reader friendly. So you're not actually like going through the particular pieces. And remember also that you always have relnotes.k8s.io as a way for searching for these things. Is that too small? It's probably too small. Let me make it bigger. There we go. You have relnotes as a resource as well. Let's just click over to that real quick, just to remind you all that it's here. So relnotes is a tool that allows you to actually pick a particular release and a particular group or area that you want to look at, and it'll actually give you the release notes associated with that particular area or release. So this is a pretty tunable page depending what you're looking at. Like, you can see just code generation release notes. You can see those code generation release notes as they relate to particular releases. You can search. Well, I don't know why that's working. Why that's not working. Show releases. Anyway, so that's another thing at your disposal. That seems pretty neat. Another thing that's happened, friend of the show, Stephen Augustus, mentions that the cluster API provider for Azure is now at V1 Alpha 2. So a lot of the providers, cluster API kind of sets the pace for some of these things as cluster API, which represents kind of a generic API that allows you to think about and coordinate the lifecycle of Kubernetes clusters. As its API generation proceeds, the providers, or the people, the implementations that are going to act as sort of the glue between the generic API that is cluster API and whatever your infrastructure provider is, they have to kind of keep up with that change, right? And so since cluster API went to V1 Alpha 2, a lot of the providers are actually coming around to that as well. AWS, Azure, GCE, the internal Docker one, which is actually pretty neat. I'd like to do a show on that one. Are now at V1 Alpha 2. I can't say for sure that GCE is. I haven't looked. In the ecosystem, those of you, there are probably a bunch of you that don't know this, but I was at CoreOS for a year before it was acquired, and I have to say that as a company, it was one of those companies that really resonated with me as a person. And so it's always kind of a shame to see things change over time, but it is what it is, right? Like we all go through it. This note is particularly sad to me. This note is that the end of life for CoreOS Container Linux. So Container Linux is no more at this point. However, and they do call this out. Oh, sorry. They do call this out in the notes, which is really exciting. And I thought actually really a super classy thing to do. Here we go. So they're calling out that obviously they're making a new OS, which is called Fedora CoreOS, which is not quite the same thing, right? Like it doesn't have dual boot partitions. A lot of the design decisions that were made into Container Linux didn't continue forward in the form of Fedora CoreOS. However, it's still another good entry into the operating system market. It's really still focused on a lot of the same design targets that Container Linux was originally aimed at. It's just really more specifically around Fedora. And what they do call out, and this is what I wanted to make clear, is that like if you are interested in continuing with Container Linux, and actually I just saw a tweet by Redbeard earlier this week. If you want to continue on with Container Linux and you're not ready to make the jump to Fedora CoreOS, they do make the statement here in their press release, which I think is awesome, that Flatcar Container Linux is a fork of it. And that means that if you wanted to continue with Container Linux as it is and just continue to work forward inside of that same operating system configured in many of the same ways, you could actually just flip over to that new version of Flatcar and continue that way. And in fact, that was actually what I was referring to earlier, was a tweet by Redbeard, who did that and found a bug, of course, because Redbeard is really good at that sort of thing. Redbeard was one of the amazing people I worked with at CoreOS. So lots of good changes there, but kind of sad to see Container Linux go away. But it's now end of life. It's been longer than they stated that it would be when CoreOS was acquired by Red Hat. I think our original agreement was significantly less time, but there we go. Let's see what you all think about that. Let's take a look. I'm gonna look over here for a second because that's where my chat for you all is. So we got Tim Downey, happy Friday. We got Jim from San Jose. He's, like I said, he's part of the Kyverno project, which is awesome. We got Sajad saying hello to everybody, and Shiv Kumar, hello, also one of the maintainers. How you doing, Shiv Kumar? And Alex, hello from Northern California. Waleed, hello. Can I do something like style guideline, e.g. set a namespace convention via policy? That looks like question 4, and it looks like it should be, yeah. I think maybe we'll play with an example of that. Happy Friday. Also from Shuting, who I worked with already kind of via email. I had a few questions about how some of this stuff works. Name conventions, you can also add prefixes and suffixes. We got Alejandro from Lima, Peru. Nice. Oh, that's awesome. I'm really glad you got the CKA. CKA is awesome. I'm glad that went well for you. And Muzufar, saying hello to everybody and the mad to see. Yeah, it is revolutionary. But, you know, it's being perpetuated in a variety of different ways. You know, it's like when you have a really good idea and people pick it up and carry it farther than you planned to, and that's really exciting to me. Like, it's exciting to see that Flatcar Linux, or by Kinvolk, is going to continue down that path. They're taking they're taking a fork of it forward, and that's really great. I mean, they also just delivered on Nebraska, which is great, a tool that replaces the container update, or the container Linux update tooling. It leverages the Omaha protocol, thus the inside joke Nebraska, which I thought was pretty funny. So people are moving on. Most of CoreOS have influenced OpenShift. That's true, although OpenShift isn't an OS, right? So there is a lot of CoreOS influence inside of Red Hat, and it really did change the product that is OpenShift, and that is actually, I think it changed it for the better, but I guess, you know, time will tell how it goes. What else do we got here? So there's a link to Fedora CoreOS, now an open source project. It's been announced. Feel free to play with that one if you want to explore. Jim Angel has put together a CKA guide for experienced K8 operators. And this is actually a good one. I think Jim's a great person. I was just chatting with him earlier today about effectively trying to replace or play with a model for replacing a CNI on his clusters, and so we were just talking through like some of the models for that, which are pretty great. So as he calls out here, this is not a beginner's guide. This is assuming that you're kind of already working through or working with Kubernetes, and you want to actually like explore how to get past the CKA based on that experience. So he's been running Kubernetes in production at General Motors since 2018. He's an active community member, and then he decided to kind of like dig into how this works. So feel free to check this article out. I think it's a really good one, especially if you're already kind of using Kubernetes. So it provides you a lot of really great, reasonable tools for that sort of thing. Sidecar container lifecycle changes. I'm pretty sure we've mentioned this in the past, but I want to make sure that it's made clear. So this article is definitely worth a chat. Sidecar container lifecycle changes in Kubernetes 118 means that there will now be a sidecar concept, right? So traditionally, I guess, if you could apply such a term, when we talk about sidecars, we generally mean that a sidecar is a container that's running inside of a pod that isn't maybe the primary pod. It's just one of the other pods, right? And so traditionally, that means that there's some like racing and stuff that could happen, because you're going to define multiple containers inside of the same pod, and they might come up at different times, and the life cycle of them isn't necessarily handled particularly well. So like say you had a logging container and your application container, and your logging container, you wanted to make sure that logging container ends after the application container exits. And that way you can flush the last bit of logs up before calling the entire pod down. And so there wasn't really a tool per se, there wasn't really a paradigm within the pod that would allow for that. But after the 118, you can now mark these containers sidecars, and they start up before normal containers and shut down after all of the other containers have terminated. And in this way, you can provide kind of a better lifecycle model for those containers that are not the primary container inside of your pod. I hope that explains the problem well and what's actually happening here, but the article gets into it in some detail, and it's definitely worth checking out. Now, to be really clear, I'm not talking about init containers here. I'm talking about 118, definitely worth checking out. I think it's going to be useful for people. I was kind of excited to see it happen when it came. All right. What else do we got? Load balancing and scaling long-lived connections in Kubernetes. Now, this is a topic I think that people frequently overlook. And you know, y'all know me, I'm into networking stuff, so I do think this is it's probably a good article. I haven't read this one end to end, but Kubernetes does not load balance long-lived connections. Some pods might receive more requests than others. If you're using HTTP2, gRPC, or others, you might want to consider client-side load balancing. Kubernetes offers 2 abstractions to deploy apps. So a little bit of a typo. I guess what he's saying is that you can create a deployment and you can also create a service. A service, on the other hand, is similar to a load balancer, but it's a really naive one. They are designed to distribute traffic to a set of pods. Talks about the way services map traffic. Talks about, yeah, it is kind of sort of round robin. And I think I talked about this in the kubectl episode, in the grokking kubectl episode, how this particular traffic pattern works, because it is a somewhat naive load balancer, right? It has no intelligence to understand that there are a number of connections, because each kubectl instance on each of your nodes is making a decision about where to send that traffic, right? And so you have things like external traffic policy and things like that can help you kind of tweak and tune about exactly how these things work. But yeah, interesting stuff. Long-lived connections don't scale out of the box. I mean, he's got some good points here. It's definitely worth checking out. But what he's highlighting here is that if you're establishing a bunch of connections or long-lived connections like WebSocket connections or those sorts of things toward applications that are hosted inside of your Kubernetes cluster, and you're using service type load balancer to access those applications, right? Then the path to actually distributing that traffic across nodes, the only real information that your load balancer might have to work with in distributing that traffic is how many healthy endpoints are on the back end. It doesn't really have the intelligence to understand how busy those things are, right? So a client-side load balancer might be better. Worth talking about. How's everybody going? Mr. Josh is checking in. He's also a Choreo. He's probably putting his hand up to say, solidarity. And then I also pulled up Cube Weekly because it had a couple other interesting articles I just wanted to talk about real briefly. Cube Weekly is actually a pretty good weekly thing. It's actually hosted by the CNCF ambassadors for Kubernetes. So it's folks like Chris Short, Bob Cullen, Craig Box, and Kim McMahon, and Michael Hassenblatt who are actually hosting this information. And they do a pretty decent job of gathering up some relevant articles from the space. If you don't follow Chris Short on Twitter, I definitely recommend it. He's always linking different articles and kind of being a great resource to the community in general, which I think is incredible. Some of the stuff I found, which I thought were pretty interesting from this particular week's episode, are Kubestone, which is a benchmarking operator that can evaluate the performance of Kubernetes and features, installations, sorry. And I thought that was actually pretty interesting. So they have a number of different benchmarks that you can apply from the operator: sysbench, FIO, IOPing, iperf, kubeperf, and actually they can do sysbench on memory or CPU, which is pretty cool. They have drill as a load balancer, or as a load tester. It looks like they're looking to actually deploy kubeperf and etcd in there as well, or etcd testing and benchmarking. And so they've already got a few pretty good useful tools inside of Kubestone, so definitely check that out if performance evaluation is something you're interested in exploring. HPE, Hewlett Packard Enterprises, acquires zero trust networking firm Sidecar. So Sidecar was the company that was actually carrying the idea of Spiffy and those things forward, right? So they were actually working on zero trust. A lot of the developers that were working upstream on Spiffy and those tools, which are basically service production identity for everyone else. That's what Spiffy stands for. And this is basically the idea that you need identity at an application layer to actually establish trust very early in the life cycle of the application as it might relate to any of the resources that application needs access to, right? And if you have identity that is instantiated at the time that the process is being created, and you have perhaps some way of asserting that the identity belongs with that particular application, then you can build real trust, right? You can build zero trust networking in that the identity that that application has is now the way that it can be constrained to access to other applications or other resources within your infrastructure. Traditionally, what ends up happening is that we end up creating these huge silos that effectively have a common set of access permissions, right? So like behind that firewall, that's where we put all the financial stuff. Behind that firewall, that's where we put all the stuff that's actually hosted in our data center in Colorado. And the way that we provide access to those resources is that we actually grant access through that firewall from some particular entity inside of an IP block. That's kind of been the traditional model for network security for a long time. Where things like Sidetail and the technologies that they've been working on come in, is that we kind of need to turn that on its head, and we got to come up with a different way of actually establishing that trust between resources, that ability to grant that access. And the benefit of that is that we can become a lot more granular if we have the idea of service identity. Anyway, that was a lot of talking, but it is pretty cool. So Josh Cillian was well presented recently, and oh, that is cool. So FOSDEM actually did a number of talks, probably not too surprising. A lot of those folks are pretty heavily involved in the Linux kernel as well. So Cillian out there kicking butt at FOSDEM. Thank you, Waleed, for the note. If you want to throw up, I mean, if you have the links, it'd be awesome to see them thrown into the notes, tgik.io/notes for people to check out. This is another interesting article, DNS lookups in Kubernetes. This gets into some of the detail that maybe not everybody does understand it. Definitely worth checking out, like how this works. They talk about NDOTs, they talk about the way that resolution works, and I think it's definitely worth checking out. If this is something that is a relatively new construct for you, like if you haven't really explored DNS to a great degree, I'm happy for you. And otherwise, I would say, go check it out. Like, this is a good article to dig into the detail. And then the last thing I was going to show was this continuous profiling Go applications using Kubernetes. And what this does is, most Go applications have, or a lot of Go applications have, the ability to enable a debug endpoint. And that debug endpoint can also expose pprof. A pprof profile can give you insight into what your application is spending its CPU time on, right? So if you got a whole bunch of different functions and you're not sure which one is actually being the cause of your problem, and you can see how this would be valuable for things like the API server or the controller manager, in which we have a bunch of different threads and those sorts of things that are actually working on different particular pieces of code. And you wanted to understand, like, okay, well, where is my controller manager really spending all of its time, right? I can see that CPU load is really high, but I need a little bit more than the CPU load is really high to actually take any action, right? And so tools like this one, where we can do continuous profiling, where we go out to those applications that we care about and we snapshot that pprof back to some registry, and then we can go back when we get alerted or become aware of the fact that we have kind of a performance affecting issue, and we're able to narrow it down to that application. We might be able to go back to the registry and take a look at what the pprof had to say, or for that particular period of time. And that is great. I mean, contextually, that's huge, right? Because for good or ill, most people who are actually trying to troubleshoot this stuff are trying to do it live, right? They're trying to do it, they're firefighting it, right? So they need the problem to still be in effect for them to actually have the tools applied in such a way that they can understand what happened or what is happening, right? With a tool like this, you can say, you know what, I'm just going to do a sampling of pprof data over time and load it into a registry. And if I see, if somebody notifies me that at 1 o'clock on Friday there was a problem, and it was with this application, then I can go and take a look at the pprof data for that application at that time and kind of build a little more context about what happened. And that's a that's a very cool thing. Like, I mean, if you've ever, been on the unlucky end of like trying to find that needle in a haystack, that would be a huge thing. So just pointing that out. Definitely worth checking out. I think I might play with this one. I think I might play with this idea in another TGIK as well, because like I like the idea of exposing pprof, and we'll talk about a little why here in just a minute as we get into the Kyverno stuff. So that was this week's notes. I hope those were helpful. Chris Nova did present, yes, and it was neat because Chris has actually presented, I think, at a number of FOSDEMs, and like I think in series, like they've been doing a lot of talking at that particular event for some time now, which is awesome. And now, and in the past, they've done a talk about you can't have a cluster without a cluster bleep, and I think that they continued that narrative in this FOSDEM talk and basically described how there's tooling, by Sysdig and Falco, which are both, or Falco as an open source project that might allow you to find those problems, right? Or how do you actually find those bleeping things, as it were. So anyway, let's dig into Kyverno. So let me just clean up my tabs here a little bit. I know, I'm a rebel. I'm closing tabs, people. Here, we're doing it. I'm not just gonna like be tab overloaded. Kyverno IO is the domain for this. It is put out by Nirmata Cloud, like I said, and the way they describe it is manage policies as Kubernetes resources, validate, mutate, and generate configurations. And I have to say, when I started looking at this, and I haven't really spent a lot of time with it yet, we're going to spend a lot of our time with it today, so I didn't really want to like do too much exploration before we all had a chance to look at it together. But the thing that I thought was impressive is that there are three different ideas here, right? So validate is the idea that when a resource is created or updated, that you can specify what you expect of that resource to be defined. And if that's not true, then you can take some action, right? You can reject it, you can warn about it. These are things that you can do. Mutate is a thing where an object gets created and you were expecting it to have particular fields, like you want to make sure that when a namespace is created, it has a quota associated with it, right? And those are defined at the namespace layer. So now all somebody has to do is say kubectl create ns, and the quota would be applied automatically, right? So that's a mutating policy. It allows you to mutate the object with some rational set of defaults, so such that before that resource is accepted through admission, right, we can actually modify that object with some mutating capability. And then generate, this one is really neat. The generate is the idea that when you see a resource be created, you can have another resource be generated from the creation of that resource. So when you see, like, so we said, when somebody does create a kubectl, creates a namespace, right, then maybe I want to deploy a config map that has, some interesting information in it that's just globally available, right? Like perhaps I want to have a config map that is deployed to each namespace that has, or maybe like I want to share a secret with each namespace or something like that, right? You could see why generate would be kind of interesting, but we're going to dig into the docs a little bit and play with those things. The one thing I did notice about Kyverno so far is that they're really trying to kind of lower the learning curve as it relates to policy management. So all of these objects, these validating, mutating, and generating configurations, sometimes they're you have to know quite a lot to be able to make a useful one, right? So I think that's challenging. Let's kick over to the docs here. So this is the repository and the README for the repository, and they're basically, again, kind of describing a lot of the same things that I described. One of the things that they are pointing out here, which I thought was useful, is that the mutating policies can be written as overlays, leveraging customize or a JSON patch, and they have some good examples that we're going to play with. And then, generating resources, mutating, validating. Let's take a look at this one. So the validating resource, this policy requires that all pods have CPU and memory resource requests and limits. And so in this object, it's a YAML document, we got Kyverno IO v1 as the API version, and the kind is cluster policy. Presumably this means it applies across the entire cluster. Validation failure action, enforce. Enforce blocks the request and audit reports violations. That's a good note there. So if in this case we see this validation fail, right, then it'll actually just won't allow admittance to the pod, which is a good one. And we define these things as rules, similar concept in some ways to the way that RBAC works and those sorts of bits, right? So we're going to match for resources of kind pod, and then the validation is that, nice. So this is actually an overlay model, right? So we know every pod has this idea of spec, and in the containers, underneath all of the names, right? Underneath all of the containers that could be associated with this particular pod, we're going to look for the resources section and the limits. We're looking for memory and CPU limits and also requests. And then the neat thing it's somewhat intuitive if you're into this kind of thing, but like what they're doing here is they're basically making sure that you have something set. So that's actually pretty interesting. What's also interesting is like if you had defined a limit range within the namespace, you could also solve the same problem, right? You could basically say that a limit range would define what a default limit and request would be for any given pod within the namespace. But in this way, you would actually get the pod to be rejected, right? In this way, the pod would get rejected and you would get back a message saying CPU and memory resource requests and limits required. So let's play with that as an example. There are a couple other examples here as well. So let's get some stuff started up here. Let's play with things. I want to jump into my terminal. Oh, also, you may have noticed my change in desktop. I know Josh did. He's mad. Traditionally I've been using, or actually for the last all of the episodes you all have seen me on, I've been using i3, and I might go back to i3, but there's no way to really make i3 have wiggly windows or that kind of stuff. And so I was like, I got a new laptop that has a video card, and I was like, all right, I'm gonna go play with wiggly windows again because it's so much fun. So, and you can also do things like, let's see, where is it at? I have my 3D gears, kind of, just kind of super goofy, what do you call it, fusion stuff, which is an older technology. It took me a minute to actually find a desktop that still supported it today, but it doesn't work. So let's do kind, create cluster. We're going to bring up a 117.0 cluster. For those of you who don't know about kind already, go check out kind.sigs.k8.io. It's a way of bringing up a local cluster effectively inside of Docker. And for this particular experiment, I'm just going to bring up a single node. I'm not going to get too creative here. And if we do kubectl get pods-aw, we can see those pods starting to register. And these are the pods that make up the control plane for the cluster, right? So we have our DNS, we have our controller manager, we have our API server, we have kubeproxy, we have a local path provisioner, which is a relatively new addition to kind, which allows you to actually go ahead and make persistent volumes and those sorts of things. I should say, it's not a new addition. Kind's been doing local path provisioning for some time, but it is a changed version of it. So bash image equals bash restart. Never. We can see our cluster, we can see our pod coming up. Everything's working okay, so DNS resolves, I can do an APK update, all those things. I'm working in front of a full-on Kubernetes cluster. So that's great. So let's go ahead and get this thing deployed and take a look at how it works. So we've got a whole bunch of really cool sample policies we're going to play with. They do describe some of the alternatives. The license is an Apache 2 license, which is pretty awesome. the they seem to have just good things to say about the other things that are out there. So we have like Open Policy Agent is the first. Obviously, Open Policy Agent is actually their goal at OPA is not just to solve this problem as it relates to Kubernetes, is to solve the bigger problem. They want OPA to apply everywhere, right? If you're trying to define policy, they want to be able to be the entity that is helping you define that policy across all of the things. Whereas this one is trying to take what you may already know about Kubernetes, if you've ever used Kustomize, which is kind of a built-in tool for Kubernetes, or if you want to handle that sort of thing, they're trying to actually just make it so that you have a lower learning curve, like I was saying before. Now, obviously, there may be some of you that are listening that haven't been through that learning curve for Kubernetes objects at all yet, right? And so there's still going to be a learning curve, but at least it's like some of that's going to be reusable for you, right? So let's dig in here. They talked about K-Rail, which is one of the ones I did earlier this year, or I reviewed earlier this year. We talked about Polaris, which is not one I was actually seeing. That one looks interesting. And then we have, they're talking about external configuration management tools like Kustomize. So let's get playing with this. Where do I do the install? I had it earlier. Boop, boop, boop. Getting started. So I'm actually going to be deploying this to a kind cluster. They do actually have a really interesting tip about deploying to EKS. Deploying on an EKS requires enabling a command line argument fqdn as cn in the Kyverno container in the deployment due to a current limitation with certificates returned by EKS for CSR. I think I was aware of this one. This is, yeah. So what's happening here is when you create a CS, so, and we're going to talk about this as we bring it up, so let's just do it and bring it up. So let's jump into our shell here. I'm actually going to make this a little bit bigger. Actually, let's do this. Oops. Clear. Copy. All right. So I'm also going to do curl -lo. And let's take a look at install.yaml. So this is the YAML that they're deploying, or that we've just deployed. And in this YAML, we have a custom resource definition, and it is in the group Kyverno IO. This is actually just defining kind of like that database piece, right? So we talked about CRDs before, but this is defining the custom resource definition for these particular objects, so that you can actually create them, and then you have like the rules around like what fields go into it. So it's sort of looking like an Open API v3 schema. So if you're curious about like what fields they take and what type of objects can be populated inside of those fields, and which fields are particularly required, and what the properties are for those things, you can explore this particular object in this way. But it's a little, a little obtuse. It's a little hard to follow sometimes, but if you're really trying to dig into the detail about how this thing could work, this is where you can get some of the detail around it. They're defining a number of different policies, a number of different custom resource definitions. They define a namespace, so they're creating the Kyverno namespace for us. They're defining a Kyverno service, listening on port 443. They are defining a service account. Oh, well, that's interesting. They're creating a cluster role binding, and that cluster role binding is going to bind the service account associated with this application to the cluster admin role. So let's see, what was the question? Is it the K8's native UX? It's kind of similar, I think. So why would I choose Kyverno over OPA over? I think I would say it's probably because of the K8's native user experience. I don't think it's particularly. I wouldn't say that there's like another particularly amazing reason. Like I think it's actually useful because of that. So they are actually, like I said, they are granting cluster admin to this service account, which I think is interesting. Like that. Let's think about that. So these are policies, and they have to have the ability to mutate. They have to have the ability to, and they only have to have the ability to mutate those objects that you have specified mutation for. So pods, namespaces, things like that. I guess to dynamically define that would be hard. So I will say that I do think that this could be hardened. Right now, like as Kyverno admin, as a cluster admin, like if I can get a hold of that key and it's not even in the kubesystem namespace, like if I can get a hold of that particular token, then I have full access to everything. And that could be a reasonable exploit. Like if you have, if you're a user and you have even read access to secrets inside of the Kyverno namespace, then you could use the token from that to escalate your privilege. So I like to see these things a little more tied down, you know, like rather than just applying cluster admin. But it is what it is. That's what's there now. They also define a cluster role, and they define that cluster role as policy violation. This one is actually using get list and watch. They create a config map, and then these resource types to be skipped by Kyverno Policy Engine, which I think means that they're doing a filtered, they're filtering the result of the feed or the fire hose that's coming from the API server. They're filtering these things out of that. So they wouldn't be looking for resources defined in any of these matches, right? So some of these things are namespaces, right? So this is, I guess it would be type namespace. What's the third column? I don't know. Maybe it's everything. Name, type, namespace, name. Resource filter might be type, namespace, name, or kind, namespace, name. That's what it looks like. That's kind of where how they're doing their filtering. They have an apps v1 deployment of Kyverno. They're giving it the service account. They have an init container that does some stuff, and they have a container that's doing other stuff. All right, so that's the whole deployment. That's actually not a lot of stuff. That's, you know, relatively concise. The only thing I said that we talked about before already that is a concern is like that stuff that's where it's leveraging the cluster admin role. So kubectl get pods-a. There we can see our Kyverno pod running. Let's take a look at what else is here. So let's do kubectl get validating webhook. So they've only got one validating webhook defined. YAML. And what I'm interacting with when I type this command, right, when I do kubectl get validating webhooks, I'm actually looking at the API construct that is exposed by the Kubernetes API server, and then I'm looking at the resource that is defined by Kyverno, right? So that particular resource, how is it configured to be a validating webhook inside of the Kubernetes cluster? We can see that it is got an owner reference, which means that this was defined by the deployment. When the deployment was created, it was the one that created this validating webhook. And that's a good thing. That owner reference also makes sure that if we were to delete that deployment, the owner reference would actually make sure that that goes away as well. Here's the webhook. We have a client config CA bundle. We're going to talk about that here in a second. I think they did a really slick thing, and we're going to talk about it. We're going to point to the Kyverno service in the Kyverno namespace, and then we have a path, policy validate, and it's on port 443. The failure policy is defined as ignore. Now in this case, failure policy means a different thing. In this case, failure policy means if for some reason the Kyverno service is not reachable or it provides us bad data back, like if we were expecting a 200 and we got like a 503 or whatever, then this failure policy means I don't want you to block that resource based on the fact that the service is not available. I want you to allow that resource if the service is not available. Now those of you who are Rory and some of the other folks, realize that this is actually kind of an interesting security thing, right? Like what if I were to DDoS the service and then submit my resource, right? Then what would happen is that the API server wouldn't be able to communicate with the service, but I would be able to communicate with the API server. And that means that I could create resources that kind of sneak under the fence here, right? So this is an interesting attack surface, and this is true of the webhook configuration. This is not just Kyverno. If you look at a lot of the webhook validating and mutating webhook stuff that's out there, a lot of them have this same feature. And so, or a lot of them have the same configuration. They make the same set of assumptions here. So I thought that was kind of interesting. Talk about match policy. Then we have the name of the webhook. We have the namespace selector. We're looking for all of them. We're looking for the object selector, all of them. That's kind of interesting. The rules are API groups, Kyverno, API versions v1. And we're looking for the create or update operation for cluster policies. And the scope is everything. And they have the side effect capability none on dry run. Now, if you want to know a little bit more about the validating webhook resource, I haven't talked about this in a little while, but let's do it. So let's do kubectl explain validating webhook configurations. So kubectl explain, incredible tool. If you're ever trying to pass the CKA or the CKAD, kubectl explain is your jam. It is amazing. You can also do this, pass it the flag of recursive. If you want to see what all of the fields are that you could possibly define for the validating webhook, these are all of the fields that can be defined. If you want to understand a little bit more about side effects, for example, so let's take a look at that. Let's drill in. We're going to look for webhooks side effects. So what this field does is side effect states whether this webhook has side effects. Acceptable values are none on dry run. Webhooks created via v1 beta 1 may also specify some or unknown. Webhooks with side effects must implement a reconciliation system since a request may be rejected by a future step in the admission change, and the side effects therefore need to be undone. Requests with dry run attribute will be auto-rejected if they match a webhook with side effects unknown or some. So if we have multiple webhooks that are going to apply to a particular object, the side effects are there to help us understand, are they going to apply cleanly to all of those objects, or are some of those objects going to be adversely affected, and how do we reconcile our way back out of that, right? If some later admission controller was trying to apply a change to this object and it got rejected, right, that next validating test said, nope, this is not allowed in admittance, but you have already modified the object, then you're going to need to unmodify the object before the next admission controller can evaluate. So kubectl explain, incredible tool. The other one we saw was match label, no, match something else. Match policy, I think it was match policy. So match policy defines how the rules list is used to match. So equivalent and exact Allowed values are exact or equivalent. Exact match a request only if it exactly matches a specified rule. For example, if deployments can be modified via apps v1, apps v1 beta 2, or others, but rules can only apply to API groups apps. So this is an interesting option that basically lets you be a little more loose about what type of thing you might be able to match that particular object. All right. Let's take a look at the other thing. Let's take a look. Actually, let me go back to my notes here. Unfortunately, with this new layout, I can't see the chat when I'm not on that page. Oh, y'all are pretty quiet out there today. Not too many questions or anything. Oh, this is interesting. Oh, let's take a look. Actually, I just refreshed and now I'm seeing things. So Rory says, I haven't seen those effects in a long time. Oh, I'm using, yeah, I know, right? I love it though. I'm using Mate desktop. I'm running Ubuntu Mate, and and so it's just using like, you know, the Compiz stuff, Compiz Fusion stuff. Rory says, as a security type, I feel obliged to say, please never use cluster admin. If there's another option, agreed. Jimbo. Yeah, this is one of those things that is interesting about any webhook. Tricky trade-offs, true. Enjoying the detailed discussion, cool. And we're busy paying attention. Right on, glad you're all here with me. Okay, so let's keep going. So we also, so that was the only validating webhook, and we're gonna play with that here in a second, but let's take a look at mutating webhooks. Get mutating webhooks. And here we see 3 of them. We see a policy one, we see a resource one, and we see a verifying one. And if we do kubectl get mutating webhooks-oyaml, we can see all of the configurations for them. So same side effects, reinvocation policy is never, and failure policy is ignored. And that's verify, mutate. Then we have a mutate, failure policy ignore, which may not be what you want. And a path for policy mutate, failure policy ignore. And the interesting thing is they are actually grabbing create and update. Whoa, that one's crazy. Hold on, let's look at this one. This is an interesting one. So in this case, this is an interesting policy. So this is a this is a mutating webhook that's defined to point all objects for all groups across all resources to the /mutate endpoint that Kyverno has. Now I haven't looked at the code. There's a timeout value here for 3 seconds, which I think is probably a good thing, and they have failure policy ignore. But when you think about it, and I've said this before, I think in this show, when you think about it, admission control is effectively like bottleneck as a service, right? Because like as soon as you have admission control in place, what that means, I mean, there's a lot of value to it. I'm not going to try and like make it sound like there isn't, because there is an incredible amount of value to having admission control as an entity. However, when you think about it, like especially in a policy like this one, this means that you're going to, on everything that's being defined, you're going to send that event to the service, and the service is going to have to determine which of those things it looks at and which of those things it replies back on, regardless of whether, for any create or update of a resource. So all of the things will be sent, and then the application, in this case, the Kyverno service, will have to determine, yeah, allow it really quickly, all right? And then however long it takes to actually make that decision, that period of time, especially under load, is going to be measured against how that bottleneck that we're talking about, right? So if it took 5 seconds to make the decision for every, and it shouldn't, that would be crazy. But if it took 5 seconds on every event that came to the /mutate endpoint, could you imagine? Like that would be really bad, right? Now the interesting thing is that you have the ability in rules here to narrow the scope of that, right? You can look for all pods, and just look for pods, right? And then have something like /mutate pods, which is only making decisions on pods, just like we see in the other examples here, right? So verify mutate, for example, is looking for resources deployments in the apps v1 group, right? Whereas this one is looking for everything everywhere all the time. So kind of an interesting point. It would be, yeah. I'm curious to hear from the Kyverno folks. I'm sure that I suspect that you have done some performance profiling around this stuff, because like, it looks like a pretty well, I mean, just, I haven't looked at the code or anything, but like I said, but like, it looks like y'all have done some really good work in like, you know, developing a tool that allows for these sorts of really great flexibility in defining these things. I wonder if you have run performance tests against those sorts of things inside of there. Now, the other piece that's worth bringing up is like that constant profiling thing that we talked about before, right? Like that would be, if it were me deploying literally any admission controller. Again, this is not related to Kyverno. This could be any admission controller. What I would want to know is the performance and this and be able to profile the API server, right? Like, is the API server spending a bunch of its time waiting for responses back from the admission controller? This would be pretty critical information to know when you're looking at productionalizing things like Kyverno or things like OPA or like pretty much any admission controller, because you need to be able to underload, make sure that you're not that bottleneck that you're defining isn't going to just completely ruin your day. All right, so we got 3 of them there. I did want to point out this one. I think this one's really interesting because it is like, this is the fire hose. This is send me everything, and I will figure out what to do with it. All right, let's take a look. So we got our pods running. Actually, let's take a look. So let's do kubectl get pods -in Kyverno. Looks like it's running. Let's do kubectl get pod deployment -in Kyverno. I meant to say edit. I think we looked at it before, but I want to look at it again real quick. I think it's fine, but so they have 1 pod running, and that's fine. Probably could scale it up or scale it down, I would imagine, because it's just making policy decisions. I do not see a health check or a readiness check. Maybe I'm missing it. No health or readiness check on here that I can see, so that's another thing to add. It's a relatively new project. I'm not expecting everything to have everything all the time. Cool. All right, let's play with it a little bit more. Let's actually kick some stuff up here and see what we can do to play with some policies. Oh, that was the other thing I want to point out. I thought this was really neat. So in their documentation, when I apply this, option 1, use kubectl manager to generate a CA signed certificate. So if I do kubectl get CSR, I can see that there is a certificate that was issued. Kubectl describe CSR. There was a certificate that was issued for the Kyverno service that is likely being mounted in by the application itself. So likely when the application comes up, it generates a CSR. It approves that CSR because it is a cluster admin, right? This isn't automatically approved. So it makes a call to approve the CSR. It takes the resulting signed certificate associated with the CA certificate that is made available inside of the Kubernetes cluster, and it issues a certificate with these 3 names. And these 3 names, if anybody's familiar with Kubernetes DNS, will seem familiar, right? Like it's issued for the service name itself, the service name and the namespace, and then the service name, service, and then the namespace. I'm surprised that it's not actually also taking in the .cluster.local, but really just these 3 should be enough to get it done, as long as you're as long as you're using core DNS as your service, right? So if we did kubectl get pods, we got our bash, right? So we jump in there, ti bash, and then we can do host, nope, apk add host, apk add DNS utils, maybe it's behind utils. Pine tools? I'll get it right one of these times, don't worry. There we go. So dig, actually, host, cool. Host, Kyverno dot, what was the name of that service again? So it is resolving to a name, and you can see that the name actually has the DNS name associated with it from the cluster. And if we were to do curl minus v minus vk, but we'd have to use the short name because the cert only matches that. Oh, add curl. Oh, sorry, my bad. HTTPS. So we can see that the certificate subject name is Kyverno service, that the host matched. Yeah, so like it's using the certificate that it learned from the cluster. We're getting a 404, so we do mutate. What about health? No health. That's right. But that's cool. Like the application is there. We can see that it's using a certificate that's in line with what we expected. That's actually, we can see the issuer is the CN's Kubernetes, so it's actually pulling the certificate from the Kubernetes cluster itself. That's actually a pretty neat thing. I've not seen another admission controller that leverages that leverages that idea, but I love it as an idea because it's actually scoping that certificate to the cluster itself, which in reality, the admission controller is also already scoped that way. So I think that's actually a really cool thing that they did. You can also use your own CA sign certificate if you want. And they taught you how to do that. We did the install. We configured configure a namespace admin configure a namespace admin to access policy violations. During Kyverno, violation has, okay. So they're saying they've created a role called policy violation, and they want you to expose it in such a way that other people can see it. That makes sense. So you could do like system authenticated or whatever, right? And just allow the view of policy violations. So we'll play with that here in a minute. For now, if we were to do kubectl get policy violations -a, we don't see any violations yet, but let's fix that, shall we? So we got that running. Writing policies. So following picture shows the structure of Kyverno policy. So we got our policy and then the rules like we talked about before. We have match and exclude, and then we have mutate, validate, and generate. And I really like this idea of generate. That's really cool. Let's play with these a little. So the following YAML provides an example for a match clause. So in the name Mongo, and you can wildcard it. That's really cool. So like in this case, it's going to start with Mongo, right? Otherwise it would be star, Mongo star. And it can also glob namespaces. A resource selector is optional. Value, support wildcards, match labels at Mongo, match expressions, operator in database. Optional subjects to be matched. Each rule can validate, mutate, or generate configurations of matching resources. So here's the information about validating. We have the ability to do wildcard 0 or more alphanumeric characters, question single alphanumeric character. Your operators are the standard operators. Anchors are conditionals. Anchors allow conditional processing, i.e. if then else, and other logical checks and validation patterns. Following type anchors are supported. I think an example is going to go like a million miles here. So child elements are handled differently for conditional inequality anchors. For conditional anchors, a child element is considered to be part of the if statement, and all peer elements are considered to be part of the then clause. So this reads, if a host path volume exists and the path equals varlog docker socket, then label allow docker must be specified with a value of true. What a neat idea. So this is a way of actually this is even a pretty reasonable example. So they're saying with a match like this, we could actually explicitly not allow things to mount in the varlog docker socket. I'm going to kick back over to the examples here, and then let's play with getting something deployed in a way that we can play with it here. Samples, best practices. So here is our example policy for the var1 docker socket. Let's play with that. kubectl apply -f. So now we have our cluster policy. We should be able to get, actually, let's do describe cluster policy. So there's our policy. And it looks like it's actually not namespaced. So I can find out if it's namespaced by doing kubectl API resources. And then looking for that particular object, grep-i policies. So here's our cluster policies, right, that we've been defined by Kyverno. And we can actually even just grep for Kyverno. Make it a little more interesting. So this gives me the idea of things that are namespaced and things that are not namespaced, right? So in our case, the cluster policies, as you would expect, are not namespaced. That's why it says false. And cluster policy violations are also false. And then we have two namespaced objects, generate requests, which is a namespaced object, and policy violations, which are a namespaced object. So let's play with this. So our idea, our policy, right, that we just looked at, was a policy that was going to disallow the Docker socket to be a part of the mount. So in our example, we're looking for validate. Why do I see duplication here? So it's going to look for deployment, daemon set, job, and stateful set. Oh, I see. So there's a pod match, and then there's a everything else match. So it's not a duplication. It's saying, but what's interesting is that we can reject it earlier, right? So in this case, we can reject it when the deployment is created, not just when the pod is created. Failure action audit. Ooh. Instead of enforce. And then up here, let's play with that. So kubectl get pod create pod. Okay, so I'm going to make this called Docker socket. Put in the default namespace. Nginx is fine, actually. Now CPU and memory. And Docker socket. So that's our volume mount. Why is that unexpected? Let's see what runs. Kubectl apply dash f. Nope. Let's go back to our example here, because I think I can just pull what I need from that. Volumes host path. Docker.sock. There we go. Cool. So that should have given us our error. Yeah, it should be host path. Thank you for that. Policy. And then cluster. Policy violations dash A. I don't see the rejection. Kubectl get pods. I see it running though. Kubectl describe pod Docker socket. Or run Docker socket. Did I misstep? Describe cluster policy. We're looking for a deployment, which is what we have here, where host path var run Docker socket. Template spec volumes host path. Our violations logged to standard out. Yeah, that's a good point. Kubectl logs dash n actually Kyverno. It says is loading variable service account names. Here we go. What's that say? Loading error syncing policy disallow Docker sock mount. Operation cannot be fulfilled on cluster policies The object has been modified. Please apply your settings and try again. Well, looks like we have some kind of a bug. Handling validation. Patch update. There's our create. Inserted annotation to pod template. So if I do kubectl git pod docker socket dash OEL. It says pod policies Kyverno autogen applied true. So something's happening. Kubectl get deployment dash OEL. At this layer, policies Kyverno patches. Policy name disallow docker sock mount patches. Rule name auto generate pod op add. Annotations. Looks like it is applying. Huh, wacky. You can use kubectl get poly all namespaces. Kubectl get pol dash a. So there is a, there we are. Okay, because I get it now. Because it's actually going to expose the policy violation in the namespace you're in. That makes sense. Okay. YAML. And because it wasn't enforced, it allowed it in. Validation error. Use of Docker Unix socket is not allowed. Validation. There we go. Perfect. So let's actually edit our cluster. Let's edit our edit cluster policy. I think what was confusing me, Jim, was I was kind of half expecting the match to show up in at the cluster level and at the namespace level, which I understand doesn't make a ton of sense, but that was where my head was at. So it is what it is. So let's change our failure mode to enforce. So then we'll do kubectl edit deployment docker socket, and we'll change something silly here. Foo bar. Actually, spec. Foo bar. Kubectl get pol dash a. Interesting. So it still allowed the creation of it. What if I do kubectl delete dash f docker YAML? Kubectl get pods. Thank you, Jim, for the tip on that one. That'll help me out. And then we have curious now somebody could get their logs into an external system for further analysis. I think it would, actually, it's a good point. Kubectl get events. We are seeing the policy violation. So, Lamati, we are seeing the policy violation. Are y'all still there? Oh, okay, cool. Okay, so now if I do describe cluster policies, and I have, hey, we even have an average execution time, which is actually pretty cool. They've really got some really thoughtful stuff that's in here that's really interestingly done. So our validation failure action is now in force, which means it shouldn't allow it in, as far as I understand from the documentation. So let's try this out. Let's do kubectl apply -f docker YAML, and boom. Error when creating Docker YAML, admission, webhook, Nirmata, Kyverno, resource, mutating webhook, denied the request. Resource, deployment, default Docker socket, failed policy, disallow, blah, blah, blah. Validation error, use of the Docker Unix socket is not allowed. Validation rule, auto-generate. Now, what was interesting though was that we noticed that there's kind of a tricky thing here. Like if it did get through, right? So if I did the edit here, edit cluster policies, and I change this to audit, and then I do kubectl apply -f Docker YAML, then it gets created. If I do kubectl get Paul, I can see the audit alert, which is cool. And kubectl get events, it's there too, right? That's good. And then we go back to our edit and we change this to audit CW enforce. Okay, so then we're going to do our, so now what's interesting is it's watching for create or update, right? So like if I did the policies here, validate, oh, actually it might just be on, it just says that it's looking for them. It doesn't say whether it's create or update, but we do know that from the webhook, it's from create or update. So we'll still get an update event. So there's that. Okay. So now if I do kubectl edit deployment, and I change this object, like down at the template layer, changed true, then at a pod level, we should definitely not see the next one apply, I would think. Oh, doesn't like the recorded true. Fine. YAML never changes. All right, there we go. Okay, so then what I would expect to happen is that although we would see the replica set try to create a new one, and that new pod that is being instantiated by the replica set should be a create. The create should be denied because of the enforce policy. Kubectl get pods. Not what's happening though. What's happening is it's still being allowed. So there's a hole in the logic here somehow. Yeah, I moved the policy. So initially my policy was audit, and then I saw the event, and then I changed my policy to enforce, and then I modified the pod object, which will create a new replica set, which will generate a new pod. That new pod will still have the Docker socket associated with it. And that new pod is making it past the enforcement. The new pod should not be allowed through. The new pod should get rejected, because that new pod, generated by the new replica set, generated by the change in metadata, should be denied by the policy enforcement. I hope that makes sense, but I can chat with you offline about it. I just thought it was an interesting little corner case. All right. So let's play with some other policies here. I want to play with the generate one before we call it a day, because I think this is actually really kind of a neat thing. Best practices, add NS quota. So this is the other one I really like. So let's play with this A. I think this is really cool. So raw, let's go ahead and grab this one. kubectl apply -f. This was the example that we were talking about before, right? So if I did kubectl describe cluster policy, add NS quota. So this one, the policy is background true rules generate. I don't know what background 2 means. I'm curious about that one. So we're going to specify generate. So whenever somebody creates a namespace, nice, and we can even reference like request object metadata name. That is neat. So request object apparently is something that we can reference to templating things. So that way, when we generate this option, then we're actually going to see that change. So this is in validation failure policy action audit, which is surprising to me. I would have thought that you would want that in. How would I think about that? So this is a generate, which means it's going to mutate the object. So if I do kubectl create ns test, kubectl describe ns test. So see how we now have this. How does the language work here? So in this case, it's saying you created a namespace, and we've defined the hard spec and the limits and stuff for you, and that's where we see them, and that's great. That's totally working. Because if I were to do that while that policy was not in place, then I would expect it to not be applied. And if I do kubectl get polv-n test cluster policy -a. See, I would expect, because you had to take some action, that audit would tell me that you took some action. Because validation failure action was audit, and because you did have to apply it, I would expect that there would be some event somewhere that pointed out that a namespace was created without this thing, and because we have failure action audit, we had to apply it. Get events -n Kyverno test. I'm not seeing an event related to so that's an interesting point. Generate will create new objects, but it would be kind of interesting if when generate created the new objects. So this in this example, so in this example, what I'm doing is actually mutating the object before it is allowed admission, right? But that was just the mutating object. So I had created a namespace, and then other fields inside of that namespace are going to be applied, right? So if I did get cluster policy, add ns quota -o YAML. So to your question, Waleed, right? We're actually going to apply this rule to the object itself, and that's why we could reference request object metadata name, inside of that same namespace, because I'm creating a namespace, and and by default, namespaces don't have any of these things defined, so we're mutating that object that is being created with these new fields. And you can even see like how that falls out, right? So it's like, we know that the namespace in the spec area has a hard field of limits and policies, right? So if I do kubectl get ns test -o YAML, right? That same, oh, did I call it test? What did I call it? What? Describe. I don't get how that's happening. ns test. Oh, this is generating a new one. I'm sorry, I'm being silly. Get resource quota -n test. So it created this default resource name. So this is creating a new object, and that new object is the resource quota. Sometimes my brain is just not with me, even in this in these weird moments. Yes, it is a new object. Thank you, Jim. I made that mistake. So you get the idea, right? So like, it's going to create a new object called resource quota, which is pretty cool. So I really like that feature. Like, that feature seems like it could be super helpful to people. All right, what else do we got, examples wise? Best practices. Using the default namespace is not allowed. And this one only applies at the pod level. Let's play with this one. It's a neat idea. Kubectl apply -f. Kubectl get run it test image equals bash. What? Oh, it's not in enforce mode. And so the only way I'll see that is if I saw it on the event or if I went looking for it. Let's kick it back up to enforce mode. Let's take a look. So, grep dash. Get cluster policy. Actually, edit cluster policy. And then we'll do disallow default namespace. And down here, validate function, failure option will be enforce. And then we can do our run again, and then this time we should get kicked. Oh. Deployment test. Now this is interesting because I am creating a deployment. So it might still allow the deployment to get created, but it won't allow the pod to get created. So kubectl get pods. Kubectl get deployments. Kubectl get Paul V. Kubectl delete pod deployment test. Kubectl get deploy. Kubectl run it test image equals nginx restart equals never. Okay, so if I create the pod directly, I see it. And I would still, so I think where I'm struggling is I'm expecting the pod to apply regardless of whether the pod is being applied by me or whether the pod is being applied by the replica set controller. And what's actually happening is if the pod is being applied by the replica set controller, it's being allowed in. So Shiv Kumar says, the resource quota is generated as part of the generate rule. The variable is used to make sure we generate the resource in the incoming resource namespace. I know, and I kind of really dug that you could actually use that string as a variable. Like, that was really cool. All right, well, that's pretty cool. So, I mean, it's a developing thing. They are open source. They've got some great engagement so far. It looks like about, last time I checked, it was like 200 stars. Kyverno IO, yeah. 22 forks, 200 stars, 10 contributors. Hasn't been around for too long. They just announced it recently. But I kind of like the intuitive way that they describe policy. And it looks like there are some challenges. Like I said before, what I was expecting was when a pod is instantiated, regardless of whether it came as part of a deployment, I expect that you would treat that pod independently of whether it was created as part of a deployment or whether it was created as just a pod. So right now there's still some holes in the logic, but you know, I mean, like, this stuff is hard, right? And they're trying to make it easier, and I respect that, and that's really cool. So it's 2:38. This is a neat project. It's really shaping up really well. I like how it actually goes about its work. I like the policy violation model. I like the option there. Oh, one more thing I wanted to show before I go. They have this testing policies thing, which is not the thing I'm looking for. There's a, where's it at? I saw something in the docs wherein you could so those are validate resources. Our examples: mutate, generate variables. So here's the variable documentation. Predefined variables, service account name. So I would imagine pretty much anything in the request object would be available to you, but I don't know for sure, but that's a neat one. And we have preconditions. Precondition allow controlling policy rule execution based on variable values. I see. So if it comes in and you're going to see, this stuff could get out of hand quickly, because like when you start adding more logic, especially like in preconditions, you could see that like it would have to work through more of the logic before reporting back to allow or disallow, right? So this could put even more stress on the actual controller code running inside of the tool. And I'd be a little concerned about how that's going to work. Background processing creates a thread, probably. What does it do? Kyverno applies policy during admission control and to existing resources in the object that may be created before a policy was created. The application of policies to existing resources is referred to as background processing. Note that Kyverno does not mutate existing resources and will report policy violation for existing resources that do not match mutating. Oh, that's cool. A policy is always enabled for processing during admission control. However, policy rules that rely on request information cannot be applied to existing resources in the background mode, as the user information is not available outside of the. That's a very good find. I bet that was a fun one to catch. Testing policies. The resource definitions for testing are located in the test direction. Each test contains a pair of files. One is a resource definition, and the second is the Kyverno policy. Oh, that's cool. So if you actually wanted to validate that these things are working the way you expect, they provide you examples of how that works. We talked about policy violations. It shows up as a CRD itself, and it also shows up as events, which is pretty cool. Yeah, I mean, great job so far. It looks really great. So let me kick over to my chat here, make sure I'm not missing anything. Can you check the auto-gen feature? It answers your question on the pod versus pod controller. Does it really? Because I didn't see an answer to that. Auto-gen. Pod controller policies. Writing policies on pods helps address all pod creation workflows. However, when pod controllers are used, pod level policies result in errors not being reported when pod controller object is created. Kyverno solves this issue by supporting the automatic generation of policy rules for pod controllers from a rule written for a pod. The auto generation behavior is controlled by the pod policies Kyverno IO autogen controllers annotation. By default, Kyverno inserts all to generate an additional rule that is applied to pod controllers. You can change the annotation, but so this is saying that by default it should apply, but it doesn't. It may be that you're missing one. It may be that annotation is defined as pod policies auto generation control deployment. So in this example, in this documentation, they're saying that it looks like it should show up, right? So like if I actually modified, so if, oh, actually no, this is a reverse match that I'm talking about, right? So in the policy, nice. In the policy that I see here, kubectl get cluster policies disallow default namespace -o YAML. So in this example, I'm saying validation feature failure action enforce. And the only matches that appeal or apply are pod matches, right? There's no match here for deployments. And what that means is that I would expect, given the behavior of many other things that I've worked with, that the behavior would be that if it's being applied at the lowest level thing, at the pod level, that anything that generates a pod would get that applied regardless. And what's happening is not that, right? But let's try that. kubectl edit cluster policy disallow default namespace. Okay. So then deployment. Okay, so then kubectl run test image equals nginx it still accepted the deployment. Get pods, and the pod's still running. I'll get Paul V. Yeah, it's still not giving me the behavior I would expect. I didn't actually. The annotation is set to none. I set it. You're right. It was set to none. I updated it to delete, or to all. You mean delete and recreate the policy? Sure. Kubectl delete policy. Control R. Control R. Apply. Delete. Curl as hello. Disallow default namespace. Apply-f. Describe policy. Disallow default. So now we have it created from scratch. We have our all. The annotation sees it as all. We have audit. Kubectl delete. Well, okay. We should still be able to see it. Oh, now it's doing a different match. Neat. So it just generated that code. You see the difference here? Like in this code, before I only had matches for pods, and now it's generated a match for the rest. That's cool. Kubectl run it tests. Image equals nginx should fail. Kubectl delete deployment test. Deployment test. I don't want -it. Not what I want. Oh, kubectl get Paul V. Yeah. So now we're seeing the match. That's pretty cool. So what just happened there, which I didn't notice before. So if we look at the policy that I was the disallow default namespace policy. The only rules in here are for pods, right? But I did autogen controllers all. So then what happens is that when I go ahead and define that policy, what I get, the resulting policy from it, actually includes some generated code. Get cluster policy, disallow default namespaces, -o YAML. So here are the two rules that were defined before, and now there are two other rules being applied with the same policy, the same pattern, just actually generated into the spec template, because it is no longer a pod. It's a higher order object like daemon set, deployment, job, or stateful set. That is really neat. So that means that if I were to define a pod policy that I cared about enforcing at the pod layer, as long as I have the autogen controllers all, whatever I defined at the pod layer should also be enforced at any higher order. which is really kind of cool. Like that's a neat feature. Thank you for catching me on that. That's neat. All right, everybody. I think that's our time for the day. Unless you all have any questions or anything I can help answer for you, I think that was really cool. Yes, thank you very much, Jim and Shiv Kumar and Shooting for jumping in and helping us answer questions. That was really fun. So thank you, and we'll see you all next time. I think next week we have none other than Mr. Joe Beta back up. He did say that he was in for next week. I'm going to be up in Seattle next week, so I won't be able to make it. But I hope you all have a wonderful, wonderful week, and keep having fun out there. So I'll see you next time.